The oil refinery, operated by BP in Whiting, Indiana, has the capacity to process more than 400,000 barrels of crude oil every day. The refinery operates 24 hours per day, 365 days per year. On an average day, this refinery produces enough products to fuel 430,000 automobiles, 22,000 semi-trucks, 2,000 commercial jetliners, and to fill 350,000 propane tanks. Determining the costs associated with a high level of continuous production requires a specific type of accounting. Companies which produce many unique products measure the cost of each individual job through job order costing. Job order costing keeps track of all costs related to specific custom orders to determine the cost of the finished product. Companies which mass produce identical or similar products use an accounting method called process costing. In process costing, a company allocates all manufacturing costs to production and divides by the number of units produced to determine an average cost per unit of production. The BP refinery in Whiting, Indiana, uses process costing to determine the costs associated with the many products they create every day. In a refinery, a barrel of crude oil is refined into a number of different products. Gasoline and heating fuel are lighter products, while greases and asphalts are heavier products. As the crude oil passes through various processing units, heat and pressure are applied to separate the products.
A refinery is a continuous process flow, so we bring crude oil in and we make everything from gasoline to asphalt coming out the back end. So those are the things that the consumer buys in the marketplace. Crude oil is the primary feedstock for a refinery, so we actually manage the accounting from this on fence line to fence line, and we typically don't measure what's happening from unit to unit. We measure the inputs and the outputs to find out how much value was actually added.
In order to determine costs for a process, you need to know the total costs of the raw materials and the total number of units processed in a specific period of time.
Well, everybody's familiar with WTI, so West Texas Intermediate, which is a nice sweet crude that makes a lot of gasoline. But you can run anything from a WTI to some of these Canadian crudes that people may not be as familiar with. And so what you're looking at is the differential between a sweet crude and a heavy crude versus the types of products I can actually get from that crude off the other end, and you try to optimize the margin over the raw material being the crude.
The price of a barrel of crude oil fluctuates, sometimes rising and falling in the course of a day. Other materials used in the refining process also affect the cost.
And other costs would be your chemicals and catalysts, which actually help in the processes. So a catalyst actually enhances the reactivity to actually make a molecule turn into something else, whereas a chemical actually becomes part of the product and goes out in the process.
To account for these variables, BP uses a linear programming model to calculate the most profitable mix of products to be produced from the crude oil input. Using current market prices, this computer model helps engineers determine which products to produce in order to maximize the gross margin of the outputs. With this model, the volume of each output and the costs are calculated simultaneously. In addition to raw materials, the cost of labor and overhead is part of the overall cost of the process. The Whiting refinery tracks these costs on a monthly basis.
So that's the repairing of the units and the maintaining of the units. I'll call it overhead. Management is a fixed cost. All labor is mainly a fixed cost. Because if we have a unit that goes down for a turnaround, it doesn't mean I get rid of my labor pool. It just means they're redeployed doing something else. Some of the operation folks actually work on the turnarounds. So we see those costs as fixed in nature, so they don't fluctuate depending on how you actually run the refinery.
In traditional process costing, partially completed units are converted into an equivalent number of completed units. These units are tracked through a work-in-process account. However, because production at Whiting never stops, the refinery does not calculate equivalent units.
There's really not a work-in-process account like you would probably see in an automotive industry or something. So if I have a crude unit, you would say everything in that unit and prior to getting to the unit is crude oil. And it would just be a constant that was calculated by the engineers based off of the size and diameters of all the pipes that all this stuff is sitting in. And it remains a constant until the unit comes down for a turnaround or it goes down for some unexplained reason.
Because the diameter of the refinery pipes is constant and the pipes are always full, the beginning and ending work in process inventory is the same. The only difference is in the value of that work in process. Since the dollar value is small relative to the total output of the refinery, its effect on production cost is not significant. Determining the costs associated with running a refinery is complex. The cost of crude oil fluctuates constantly, as does the price of gasoline and other products into which the crude is refined. By calculating process costs using a linear programming model, BP can manage these dynamic variables and set production at a level that maximizes gross margin. This system ensures the best use of the precious crude at its refineries around the globe.